Good morning, everyone. Thank you for joining us for this new Webtech session. And today, as you already know, it is, regarding Ignion, the antenna technology, and they want to share their experience in the expertise in multiple frequency antenna for trackers. So mixing different, technology on the same trackers. It's an asset tracking design guide that Jordi is going to present us. Good morning, Jordi.
Good morning.
I just few slides. We have about completed more than 120 Webtech already, and if you want to stream the recorded Webtech, we have about 100 replay available on our website, so you can go through the chipselect.fr website and select the one you want to review. There are a lot with the different partners that we have, including Ignion, where we have been explaining the technology and also the service, the service provided by Ignion. The Webtech replay are available 24/7, so take your time and enjoy them. And just there is 2 more to come. We're trying to do regularly this Webtech, and the coming one that is in April will be 2 sessions, French and English, for this session, and we will be regarding the energy harvesting, how to enhance the design performance for an energy harvesting project. Last but not least, your feedback is very important, so please give us your feedback. Send us your mail at info@chipselect.fr. Do not hesitate, and tell us what you like, what you would like to see, what you don't like. Hope there is not too much, and also we have our page on LinkedIn, and don't hesitate to follow the activities that we have, Webtech, but also Mailtech that we do provide. Okay, so that's it for my side. I'll give you the stage, Jordi, so you can take it over, and I'll go back to for the questions. In the meantime, do not hesitate to ask questions. We will review and answer the questions at the end of the sessions. Use the chat window to put your questions, and we'll take care of them at the end of the session of Jordi. Okay, thank you, Jordi. It's you.
Thank you so much. Hello, everyone. This is Jordi Miró, Product Marketing Manager at Ignion. And thank you also, Chipselect, for the room to speak about asset tracking. Today, we are going to explore the main challenges and topics related to antenna integration. So part of my jobs, I spent 5 years dealing with customer projects, so integrating antennas in different customer devices, from smart meters, asset trackers, that is especially the case for this webinar, but also wearables and so on. So in these slides, there is also my experience and the experience of a very technical team behind all of this information. So let's start. Starting by the challenges in IoT and tracking and how Ignion solves them. We deliver our solutions knowing that RF is hard. So with our technology, the virtual antenna technology, the cloud-based tool, and based also on our 20 years of experience, we make it easier for you in terms of RF. For example, in one of the main challenges of antenna integration, that is a multiple band or a global coverage, or antenna portfolio, it's able to cover any band with one antenna. Also for the trend miniaturization of the devices, so ever smaller designs, we deliver market-leading performance and size. Considering also environmental challenges, we make connectivity the first consideration in your design. And also one of the most important things for a device, for a designer, is the battery or the low power consumption. So the battery efficiency is one of the topics that are important the most. So a high antenna performance is a must for you. So it enables the lower power consumption. So to put a bit of context on what is our solution, it consists in two main elements. We have the hardware part and the software part. The first one, the hardware part, is the virtual antenna technology, which consists in three main elements. We have, you can see the pointer, right? Yeah. We have the first one is the antenna component. So it's the red part number from a family of 6 products, from smaller to larger ones. Its non-resonant nature enables to cover any frequency bands thanks to the second element of the virtual antenna technology, the matching circuit. The matching circuit consists in lumped components. You will know very well there are inductors, capacitors, and resistors. So you are able to fine-tune the antenna impedance through the matching circuit. So it enables to adapt the antenna to multiple bands. From the frequency range of the virtual antenna technology, it's able to cover from 400 megahertz up to 10 gigas. And then last but not least, we have the ground plane. So once you have the antenna implemented and the matching circuit tuned, the ground plane is the main radiation element of the system, helping the antenna system to radiate at maximum performance. All of this, the hardware part, it's also combined in tandem with the Antenna Intelligence Cloud design tool. That is the software part of the Ignion solution. This consists in AI/ML powered digital twin that is free of charge. You can visit in our website, ignion.io. It's a red button in the right top corner of the website, on the main website. And basically, you will have a form. There is a 1-minute fill-out form, and you will put there the PCB dimensions of your device, for example, 100 by 50 millimeters. You will put all the wireless technologies that you need to cover in your solution. And then this cloud tool will provide you with antenna location. Well, first of all, antenna part number. You can click whatever antenna you want to use from our portfolio. But also, if you don't know very well our portfolio, the cloud tool will decide the optimal one for you. Okay. And then you will receive the antenna per number, antenna location, clearance area, basically all the design recommendations that are important in antenna integration. Also considering the matching topology, a bill of materials, and included in this report through email, you will get antenna efficiency, S11 reflection coefficient, and also additional design recommendations for your device. So basically, the Ignion solution is a tandem between hardware and software that from the very beginning of the design stage of your device, from the idea stage, you will be able to pre-assess the performance of your final device. So here we can see the antenna integration challenges in asset trackers, but also for any device that is there is a multiple antenna in the device. That consists, first of all, the coupling effects, which is the impact between the two antennas, two or more antennas in the same device. This impact affects the S11 and also the antenna performance. Another main challenge in asset tracker and also in asset tracker is the worldwide coverage. An asset tracker typically needs to cover all the ranges, that is, all the ranges in cellular worldwide, and this means a very wide frequency range. So the wider the frequency range, the most complex will be the antenna configuration. Also, one of the challenges that is also affecting the antenna performance is the materials in proximity. For example, in the slides, we have a container tracker that is typically made of metal. So the device deployed in a container tracker near to the metal will be affected by this metal, affecting antenna performance. So in one of the last slides of the presentation, we will see how the materials affects the antenna performance. Certification stage is one of the last stages of the prototyping. It is very important also because there are RF or performance certification targets that needs to be surpassed if you want to launch the device in the market. And also, of course, the battery life. That's for a better battery life, it is needed a high antenna performance. So, starting from the beginning you have the idea of your device, so you need to to build the device. Ignion recommends the following design journey. Starting from the feasibility stage, okay, we have, as I said, the Antenna Intelligence Cloud, so it's the software part of the Ignion solution. Here you will be able to pre-assess the performance of your device. So we will recommend to start by this stage, that is a free of charge, and you have then available design files for the antenna location and the antenna footprint to start starting from the scratch. At least you have these design files to start with the rest of your design. The second stage is the Gerber, building the Gerber files for manufacturing your device. So it's very important to follow the design recommendations for clearance area, antenna location, antenna footprint, and so on, and components placement. Ignion also offers this free of charge service. It's a Gerber review check that will allow you to ensure that all the antenna parts are correctly implemented. For a complex designs, we recommend also to perform with your simulation software. You have many on the market. You have CST, you have HFSS. Any of them is useful for this stage to consider all the elements implemented in your device. Let me explain further. You have the casings, have metallic components such as metallic screws, batteries, and also if you have considered the deployment of your device, consider also if it is going to be implemented in a concrete wall or in a metallic wall, to consider also this as part of the simulations to have a most accurate performance of your antenna before manufacturing. If you don't have any simulation software, Ignion offers this software, and is included in the link on the bottom of the slide, so you can see there all the services that Ignion offers. Then here we provide we consider all the elements, such as if you provide us with the 3D files, we can consider everything that you want to consider in the simulation, and then you will be provided with the antenna performance, radiation patterns, and so on. Then we jump off to the prototype stage. Here, from simulations to manufacturing, there are always differences between the simulation world and the real world. So a matching network fine-tuning is needed. You know that the virtual antenna technology consists in 3 elements. So the matching circuit, most likely for a complex designs or for a multiple radio designs, will need to be fine-tuned. So the topology is not needed to be changed because it will be the same, but maybe the bill of materials needs to be fine-tuned a bit. Also, we recommend to consider these materials in proximity to test the performance in the final environment. Okay, and of course you can do this in your facilities, test the antenna in passive measurements in the real design, or you can just submit Ignion services for this stage. Then last but not least, once you have everything, the firmware part, the hardware part, and then integration done, we have the certification stage. So you have, for the cellular part, for example, we have TRP and TIS that are topics that needs to be surpassed. There are targets sorted by region. We have for North America, we have some bands that needs to be certified. For Europe, you have some bands also that are typically the band 8 and band 20, for example. And all of this needs to be surpassed, and it is related to antenna performance. So following these design recommendations from the very beginning, from the feasibility to the design to the final device, it will allow you to have the optimal performance to not have any issue with this stage. So on the design stage, there are typical mistakes when designing antenna for IoT. As I said, those are related to the design recommendations that we provide from the very beginning, from the Antenna Intelligence Cloud report. And this consists in not considering the influence of the antenna location, clearance area, the materials in proximity, the casings, batteries, and metallic screws. So here you can see one of the not recommended examples. For example, having the batteries just near to the antenna, to the red part number. This well, I have a lot of examples from my experience, but you can experiment a 3 dB decrease of your antenna performance very easily just by putting the batteries just in front of the antenna. So it is very important to consider the battery placement, the casings, and so on when considering the antenna performance of your device. So this is one of the many examples that Ignion delivers. This is a triple radio device with virtual antenna technology. Here we are delivering, I have the pointer, right? Yeah. Here we are delivering with the Trio MX10, the larger one that we have, LTM/narrowband IoT in an active solutions. This means that we deliver in the black trace LTM/narrowband IoT full range from 700 megahertz, the band 12, up to 2.2 gigas, okay? Surpassing all the certification stage. We did also the pre-certification stage with this device, and all of the targets were surpassed easily. Then in the same clearance area, this is one of the advantages of the virtual antenna technology. In the same clearance area, we have the GNSS part with the Duo MX10, delivering GNSS in the red trace, over 70% of efficiency. This is a very small form factor, so this is a very complex design that needs the full design journey, feasibility, the Gerber check, electromagnetic simulations, and so on, and manufacturing stage, fine-tuning machine network. And also this very tiny component, well, we have the zoom in here, the Nano MX10 that, well, the name is very related to its size, delivering Wi-Fi dual band capabilities. We have here the green trace, and it's over 50% in the lower range and over 50% with a peak of over 70% in the 5 gigas range. We don't have a solution portfolio that is very limited. We have limitless possibilities with virtual antenna technology. You can stick to this example and follow it, but also you can also submit through the info of our technical team with your specific needs. So there are a lot of possibilities when integrated an antenna for a triple radio. Of course, there are more examples. Here we are one of the most typicals, but also there are Wi-Fi/LoRa, LoRa1/GNSS or ultra wideband and so on. So there are a lot of examples, but this is one of the typical examples that we show. This is one of the recent ones. This is for this year, end of the last year. So do not hesitate to check out our documentations in the Ignion portal, or also sending an email in the info ignion.io. So if I would say one of the most important things when considering antenna performance, I would say PCB dimensions. So here we can see an example of a PCB implementing GNSS and LTM with the Trio MX10 and the Duo MX10 for GNSS, SES, and LTM/narrowband IoT, a full range. Okay, from 142 millimeters length by 60 millimeters down to 50 by 50 millimeters. So there are 6 examples. And then focusing on the right side of the slide, we have S11. We can see here from the 50 by 50 millimeters up to the 142 that the performance is getting better and better and better. So it's very related, the PCB size, to the performance. Also focusing on the antenna efficiency. S11 is related to the antenna efficiency from the very small PCB, 50 by 50, over 10% of efficiency, up to 142 millimeters. So the efficiency gets higher and higher. The higher band of the solution, in this case, it is related also to the dimensions, but it doesn't get that affected by the PCB length. It's more related to the width of the PCB. So consider also this topic for your device. So on the certification stage, there are also best practices to follow. We have, for example, this is one of the typical examples that customers sent us as a question. That, okay, my RF module covers from 700 megahertz up to 2.2 gigas. So I want to cover the full range. Okay, but where will be your device deployed? Europe. Okay, you must consider that the certification bands, the bands that you will use in Europe region, for example, will be 28 and 3, band 3. So it is a multiple band, but you don't need to cover from 700 up to 2.2. Okay, there is another example. For example, in North America, in the table here, we have band 2, 4, and 12. So these uplink ranges will be certified in TRP and also here in TIS. So you need to focus on these ranges specifically to surpass the certification stage. So one of the best practices is focus on the deployment bands because the rest of the range is not that important. So the virtual antenna technology through the matching network is able to focus on these deployment bands, enhancing the performance in that point to be sure that the certifications will be surpassed. Also considering that you will have okay performance or good performance in the rest of the range if you want to cover the full range. But the most important ones is the bands that are going to be certified. Of course, the second one is following the design recommendations that are available in any of or in all of our documentation, application notes, user manuals, but also in the Antenna Intelligence Cloud report that if you submitted a fill-out form, if you submitted an Antenna Intelligence Cloud submit, you will receive these design recommendations specifically for your case. So you can follow these design recommendations to ensure that you will surpass certifications on the last stage of your device. Also, it's very important using high quality factor or low loss components in the matching network. So because if you use very high loss, very lossy components, this will incur in losses in the antenna system, and losses in the antenna system became a lower antenna efficiency. The lower the antenna efficiency, it's more difficult to surpass certifications because you will have a poor antenna performance. And also, before going into the certification stage, because this stage is very expensive, the official certificators, the services are quite expensive to have your device certified. So it's very important to ensure before this stage that you are surpassing this tier PTIS value. So Ignion, for example, offers in their facilities pre-certification stage delivering over-the-air measurements. So you will be sure that you will pay once and you will surpass the certifications. So you will be ready for the market launch. So referring to battery life, there are two slides here. One is for any, for example, for the cellular part, we have two cases. Optimized antenna impedance will mean that all the injected power through the RF module will be going through the antenna system and will be radiated. The radiated power will be very related to the injected power. So it means the antenna system is okay. You will have a good battery life. You will have a reliable communications, and you will have a longer range. So it means you have an optimized antenna impedance, and you have a very operable device for many years. And you have another case when you don't follow design recommendations for antenna integration. And this means for the worst case, okay, this is the worst case, that all the injected power is reflected again through to the chipset, which means you have a very poor battery life because you are overheating your chipset to ensure that you are communicating properly. Okay, you have very poor quality of communication, you have a reduced battery life, and even in the worst case, your chipset can be damaged. Okay, so this is a very suboptimal case, and this is something Ignion also tries to be clear in this, that we focus on delivering the higher performance for your device, not only in the antenna, but also taking care of the chipset, so the rest of the RF system. The second part for battery life in asset tracking, this is specifically for asset tracking. The last one, the slide before, is for any case, okay, for any cellular part or for any wireless technology. For this case, we have the time to first fix, that is a GNSS concept topic. Okay, the time to first fix it measures the GNSS device signal acquisition time. So it means this stage is one of the systems that, let's say, in a tracking device that takes more from the battery. So the consumption here is very high. So the time to first fix is very recommended to be as lower as possible. Okay, the time measured in seconds. So the acquisition time must be quicker. Here we have a study that we did comparing the virtual antenna technology in red with the Duo MX10. I forgot I have the pointer. The Duo MX10, okay, in red, compare with a setup building a patch antenna, okay, that is typically one of the most used antenna for GNSS in the past. But you will see that virtual antenna technology also delivers better performance in this case, because we built a setup and we put it in the back car, the rear part of the car, in the front facing up the sky, and then in the back seat, under the seat, sorry, and in the upper seat. And then you can see how the time to first fix is quicker, okay, in any case compared with the patch antenna. This case is pretty savage because it's in a city. The virtual antenna is quicker, so it means the battery consumption for the virtual antenna case is lower. So the case for the Ignion solution are better for asset tracking. Okay, one of the topics that affects the most for GNSS in patch antennas is that you need to put the antenna facing up the sky. In this case, for IoT, for example, a container tracker typically is oriented in the horizontally, so it's facing the horizon. It's not facing up the sky. This reduces the performance, for example, for a patch antenna, but not for the virtual antenna technology that follows an omnidirectional pattern. So it means despite the orientation of your device, you will get this quicker time to first fix, and also ensuring that you get tracking position optimally. Okay, for the materials in proximity, we have this example. Okay, let me explain a bit, because here there are a lot of graphs. We have this we put this PCB, this PCB 100 millimeters by 50 millimeters. Okay. Let me back again. We put this PCB in wood, in concrete, in a phantom body, considering this is a human or this device is placed or deployed close to a human animal body, and a metallic wall at 5 distance, at 20 millimeters, 15 millimeters, 10 millimeters, 5 millimeters, and 0 millimeters, which means from the good distance to the device is touching the material. Okay? For the first case, okay, from left to the right, in wood, there is no issues, okay, in terms of antenna performance. It is okay to place the device close to wood because it doesn't mean any loss in the system, so wood is not affecting antenna performance. For the concrete case, for distance in free space, 20 millimeters, 15 millimeters, it is okay. But once you go closer and closer to the concrete, the concrete incurs in losses in the antenna performance. So keep some distance is recommended. You won't have a very poor antenna efficiency. You will have a good antenna efficiency, but you will get some losses. So it is good to keep some distance here. Considering the human and animal body, okay, human body impacts in the antenna very much. So it is very recommended to locate the wearable or the device locate the placement with minimum body end-frames. So the most typical example is here for a smartwatch, or maybe here for a headset. Okay, but these wristbands that are in your chest, this is one of the examples that are more critical in terms of antenna performance, because there the influence in the body is very higher. So you can see here how for the touching case, the antenna performance is, well, compared to the free space, there are a lot of difference. Okay, it's more than 3 dB of losses. So it is important to keep some distance and also locate the placement of your device in an area that is with a minimum body influence. And last but not least, we have a metallic example. Okay, here is very important to keep metal at distance of your device. Okay, because antenna and metal are not good friends, and it is very important to fine-tune the matching network, considering the impact in the for example, for a container tracker that I explained before. It is important to consider the metal when you are fine-tuning the matching network in the prototyping stage. So we can see that the performance in the higher bands is very different once you put more closer and closer the device, and also in the lower band compared to the free space. Okay, the solid trace for each of the cases is the free space case. It gets lower and lower once you put the device closer and closer. Okay. So to finalize this webinar, we have a couple of examples of success story with Ignion related to asset trackers. We have this example that is very challenging. Is a global cellular plus GPS with the Triome extend. Okay, so it is a dual port solution, delivering LTE for this branch and GPS for this branch. Okay, and also Wi-Fi / Bluetooth. That is hidden in the casing, but is with the Nanome extend. This is a 82 by 35 millimeters PCB or device size, and weighs only 30 grams. So it is a very challenging solution, but virtual antenna technology and the Ignion solution delivered here high performance. And this is one of the examples that it doesn't matter the challenging, the virtual antenna technology fits to your needs. And this is another one. This is a container tracker is delivering LTM and high quality GNSS, also through a dual port with the Trio Mix10. But as I said before, there is not a solution portfolio, a limited solution portfolio. So we have the Run Mix10, we have the One Mix10 that are more space efficiency and more space efficient, and also more cost efficient. There are a lot of solutions for you that fits any of your needs related to cost, related to space, related to performance. So don't stick to the examples that I put here. Just submit one of them, for example, submit an Antel Intelligence Cloud tool, and then you will get your solution for your specific needs. But also you can reach out to our technical team to have a tailored solution for your device. All the information contained in this webinar, it is shown also further explained in the asset tracking design guide. You can just click on the link or scan the QR code to access to this content. And here you will see enhanced PCB size influence, clearance area influence. It is explained further the certification stage with an example with a PCB. Here I didn't show the performance and the TRP TIS values for a specific case. In this design guide it is included. So there are included more details here. Otherwise this webinar will last like 1 hour and a half. But do not hesitate to access this. Download the PDF, is free. But also you have my email, and if you have any further question that I didn't answer in the webinar, just do not hesitate to reach out to me, okay, or team. That's everything from my side. So maybe we can start with the questions, right?
Yeah, thank you, Jordi. Thank you. Very interesting. Yes, we have several questions coming in. I'm going to start from the first one. Okay, and if I miss your questions, don't hesitate to send me a quick note on the chat window. Okay, the first one is from Fatima. And the question is, are 3D models of the antenna available for simulation, for example, with HFSS?
We have on our website, in any of, you can check in the product section of our website, we have the 3D models for CST. We are working on the HFS examples, but there are some parameters that are available in the HFSS software, but you will need to reach out to the info mail. It is it is in the slide, info@ignion.io, okay, and just submit it there because I think it is not yet in the website.
Okay, thank you. Sam, still Fatima has another question. Have you some antenna design reference for the LoRa China 470 MHz 510?
There are two examples in our website. There are a blog post for LTE 450 that is closer to the one that you are requesting, but it can be related, so it can be just fine-tuning the matching network. You can get this frequency range, and also included in the smart metering design guide, also available in our website, that includes further information and further examples about 450. In this design guide, it is explained also 450 plus a full range LTM, because in Europe, LTE 450 for a smart meter is very important also.
Okay, thank you. Miriam has a question. I guess it's probably, equivalent for all the antenna. GNSS antenna is active antenna or passive antenna?
Our GNSS solution are passive. It consists in a virtual antenna plus a matching network, and then it is always recommended an LNA, a low noise amplifier, and that's it. It's a passive.
Okay. We have a question from Jean-Louis. is the IA tool you have also able to design antenna for ultra wideband kind of signal?
Yes, or the AI or the Antenna Intelligence Cloud tool is able to cover from 450 up to 10.6 gigas, including also ultra wideband for a specific for specific topics related to ultra wideband. For example, I cannot recall right now, fidelity factor, group delay, and so on. It is not included in the Antenna Intelligence Cloud, but you can request to our technical team to have a specific simulation for you for ultra wideband, and then it is included there in an electromagnetic simulation service, all of these considerations. So yes, it is included ultra wideband also.
Yeah. May I add one more thing, Jordi, if you may? In general, when you ask for reports and simulations directly from the link, sometimes you have a special shape of your PCB. So in that case, you should you start with probably the closest rectangle or square solutions. And then don't hesitate to send an email to the Ignion guys, the technical guys. Usually they come back to you and they say, okay, you have a special one. Then we need to do a different set of simulation on the side. Okay, it's not fully automatic. Okay. I have a question from Muhammad. Can we also use antenna from other manufacturers in the simulation, or it should always be antennas from Ignion? It's a good question, eh?
Yeah. I mean, Ignion antennas.
Yeah.
Yes. Of course, all of our customers are welcome to ask anything to our technical team, but we must work to deliver Ignion solution. But in case, for example, this one example that is very typical, the bill of materials for the antenna is split between one manufacturer and another. So if you have Ignion antennas in your solution, also coexisting with another manufacturer that, for example, is not delivering a support there, we can provide design recommendations and so on to coexist both antennas.
Yeah. And I add on the top of that is that, yes, the business of Ignion is to sell, antenna. It's not it's not to provide a service, of simulations. The simulation service and all the support service, which is part of Ignion, value. They have a large team, and this is to expedite. It's a time to market for your design. So it's to prevent you to spend too much time, too long time, and too many PCBs to do fine tunings.
Exactly.
Okay, Muhammad has another question is, do you have apps note or design example for a BLE antenna?
Yes, we have a family of 6 products in Ignion. So we have application notes. If you go to the product section, we have application notes for the Nano extent, which is the smaller one we have in the portfolio. It's a 3 by 2 millimeters antenna size. We have also for the Duem extent that is a bit bigger, so it means delivers a bit better of performance. And also for the Random extent and the One extent. We have 4 examples delivering BLE solution.
Okay, good. Mariam has a new question. Is what was the reason that you can have lower TTFF with Ignion? What was your GNSS chip?
Sorry, let me.
I think this is related to the slide where you compare probably the time to first fix.
Yeah.
So the reason is, what is the reason that you can have a lower time to first fix with Ignion versus the others, and what was the GNSS chips?
Yeah, actually, this is a very good question. So we did a setup comparing a patch antenna, so two separated setups, one setup for the patch antenna and one setup for the GNSS. So it was a GNSS receptor built in our facilities, and then we perform same examples for the four cases I explained before in the card: the rear front, upper seat, and below the seat. And then the TTFF was quicker. We have a quicker acquisition for the Ignion antennas. I could explain further, but maybe we can have a separated through email. But basically, it consists on the position of the patch antenna that needs to be faced up the sky is one of the examples. But the omnidirectional pattern of the virtual antenna technology allow it to perform a quicker TTFF acquisition. Maybe there was a link here. Maybe I can paste it in the chat during the question to go to the article that everything here is explained with all the information you will need for this TTFF explanation, and then you can read it because here there are a lot of questions. So further explanations it's on the article.
Okay, I mean, anyway, Jordi, you will have Mariam email address, and Mariam, we will make sure you get Jordi emails, everybody. Okay, I have a question from William. What solution do you have to increase the antenna performance? For example, in the 7 megahertz band, with the PCB is too small and the form factor is fixed.
Okay, so I'm assuming that the PCB is too small, that a standard chip antenna solution or a standard antenna solution is not able to cover a good performance for 700 megahertz. Then Ignion has a solution that is active. It consists in a switching architecture. Okay, so the virtual antenna system then becomes the virtual antenna, the active solution, which means the matching network becomes an architecture consisting in a switch and 4 branches that you can, through the switch, change the performance of the antenna impedance of your antenna system, and then allowing you to match the antenna impedance to any of the bands that are needed in your deployment, which means we optimize the antenna performance. So the PCB is working, being smaller, is working as a bigger PCB. So in the example for a triple radio, I can share. For the example for a very small antenna for PCB form factor, here, actually this is an antenna and a switching architecture. So we have the virtual antenna and then the switching architecture here that enables the higher performance for a very small form factor, allowing you to surpass any certification target in the market.
Okay, where I'm getting lost. Yes, it's here. Muhammad had a new questions. Also, for the Gerber check and the antenna simulation, can you also load the PCB stack? I'm not sure I understand the question, to be honest.
No. I think it means for the electromagnetic simulation service, if we are able to load the PCB stack. Yes, you can deliver or 3D file or the 2D file, and then sharing your PCB stack, and the simulations will be according to this PCB stack, considering any element of your device, if I understood correctly.
Okay, that's fine. Okay. New question from Fatimata, sorry. Do you have some evaluation board with your antenna?
Yes. On the website we have in any application, if you go for any application note, there are part numbers there for the evaluation board. That is typically the part number form factor is EB, and the name of the antenna and the wireless technology. It means that this is launched commercially, so you can buy the antenna. It is in all of our distributors. So yeah, on the website I think there is the distributor section to buy or to buy any evaluation board. We have for cellular, for all of our antenna portfolio, multiple radios. We have a lot of, so feel free. Otherwise, you can contact me and I can deliver with any sample.
Okay, thank you.
I put on the chat the article for the TTFF explanation, because I think the article will explain better than me.
Okay, thank you. Yes, here. Mariam has a question. If your antenna is passive, what do you mean with power consumption?
Yeah, power consumption for our world, okay, for the antenna world, it means that our duties are related to antenna performance and the S11. So if we, for example, deliver a solution that is very lossy, that has lossy components, the S11 is, for example, 3 dBs, or basically the S11 is built in a way that reflects half of the power through the chipset. This incurs in a very poor power consumption. So basically on the antenna integration, our duties are in delivering a high antenna performance and also having solutions that have, for example, a quicker time to first fix. Okay.
So I have a question. This is the last in the list, and this is from Roman. He's kind of skeptical about, the test on the GNSS. So he said it's some kind of cheating, as the GNSS patch antenna placing rules are neglected. Do you have a side-by-side comparison with another ceramic antenna, for example, New Hanson or Molex?
We have an application note also comparing ceramic antennas, I think. Let me... Yeah, I can put it on the chat also. Give me 1 second.
Yeah.
Because this is one of our most download application notes, because I think there are a lot of concerns about comparing omnidirectional antennas, I understand, and patch antennas. I think it's this one. Yeah. In the meantime, there are more questions?
No, this is the last one.
Okay, perfect. So give me 1 second, ensuring that this is the correct application note. Yes.
Oh.
So here we have another one. The application note for the Roman question. Both of this article and this application notes are the one comparing virtual antenna technology, chip antennas, and patch antennas on asset tracking for GNSS.
Okay, so this is giving some kind of answers to Roman. That's the test, how the test has been done. Is that correct?
Yeah.
Okay.
Exactly.
Good.
I think there is another question. Thanks.
Yeah. So thank you to all of you. I don't know more questions. If you have some that are coming afterwards, do not hesitate. I have a question. From Vitor. Jordi, is possible to have one antenna for Wi-Fi?
I mean, samples, yes. Just, I think this one is the mail for, let me check. Yeah, this is the mail for any evaluation board acquisition samples you may have. Just send an email to the info mail, and then you will get everything you need: evaluation boards, antenna samples, and in fact, any questions you might have. This mail will just redirect to our support team or me sometimes.
Okay,
So do not
Vitor,
hesitate.
yeah, Vitor is precising a little bit his question. It's one antenna for 3 bands.
Yeah,
Wi-Fi.
we have an application. We have an application node with the trio, the larger one, enabling LoRa plus GNSS plus Bluetooth thing, 2.4 gigas Bluetooth / Wi-Fi. I can share it also, but basically it's on the resource and support section on the application notes. Let me share this one, and this is the last one, because it's.
Yeah, this is the last one. If you no, you know what?
I can spend the whole morning sharing application notes.
We can. Yeah. Yes, we can share. Victor is asking if we can share the application notes. If we will send you a mail, Victor, with the link for the application notes. Okay. So. Yeah. We are close to the end. 4 minutes to go. Thank you, Jordi, for your presentation. Thank you to all of you to have participated to this Webtech. The presentation will be sent, and the streaming will be available in 24 hours. Okay. Thank you, all of you, and I wish you a nice rest of the day. Thank you, Jordi.
Thank you, everyone. Have a nice day.
Thank you.